Good afternoon, everyone. Welcome to the fifth week of the NPTEL course on Calculus for Economics, Commerce, and Management. Let us just wait for a few minutes to let other people join. Okay, so let us get started now. This week we learned some rules about limits, and so these questions are also on limits and making use of those rules to find out these limits, and also some questions on continuity of functions. So let us begin with the first question. Does the limit when x tending to 0 exist for the function fx equals 1 over x minus 1? Options are yes or no. So I will start with the true false type, yes no type poll, sorry. So take a few minutes to find out the limit, if it exists or not. Okay, so let us now discuss the solution. So I need to grab my pen. Limit x tending to 0 of the function. Here you see that we can actually directly put x equals to 0 because uh, the denominator is not blowing up, nor is it becoming 0. So the numerator and denominator, they are not blowing up. So here we can actually directly put x equals 0, and this gives us -1, which means that the limit indeed exists and the value of the limit is -1. So many a times you can see whether if you can put this value of x directly into the function and see if you get the limit. But if either the numerator or the denominator or the function itself means starts becoming 0 or blows up at that particular value of x, then you need to look at other ways of finding the limit instead of just plugging in the value of x. For example, if this x would have been x tending to 1, then you cannot put in substitute the value, because 1 minus 1 in the denominator will become 0, and 1 over 0, that will be an undetermined form, undefined form, indeterminate form, so to say. So that's what you need to keep in mind before just directly plugging in the value for x. Okay, so that was simple to start with. Let us move to the next question. Consider the limit x tending to 1 for 1 minus x squared over 1 minus x, x not equal to 1. Then the options are: the limit does not exist, the limit exists and is equal to 0, the limit exists and is equal to 1, or the fourth option, the limit exists and is equal to 2. Let me launch the multiple choice type poll this time. Take a few minutes to answer. Pardon me. So it's always a good practice to try and answer the question before we discuss the solution. That way you will have some idea of what's going on, and it will help you see whether your attempt is moving in the right direction, or if you need to learn some new concepts to solve these problems, and whether you are able to apply whatever you have learned in the lectures to the problems. Okay, so let us now discuss the solution. So this is an example of what I was discussing earlier. So you see that if we plug in x equals to 1, so let's just see. So if you just plug in x equals 1, you get a 0 by 0 form. The numerator also becomes 0, denominator also becomes 0. So this is a 0 by 0 form and it is indeterminate. Now whenever you have these kind of forms, the following rule comes in handy. It's called the L'Hopital's rule. And what it says is that if you have a 0 by 0 or infinity by infinity form, or when you plug in the value for x in the limit, then the limit x tending to say x naught fx over gx, if you have this numerator and denominator, this is same as limit x tending to x naught f prime of x over g prime of x. So you take the derivative of numerator and denominator with respect to x and then find the limit. So here that would mean the following. Now we take the derivative of the numerator with respect to x, that makes it negative 2x, and denominator derivative is negative 1. So this is limit x tending to 1, 2x equals 2. So the correct answer is option D, limit is equal to 2. There is another way that you could have used to solve this. So you see that 1 minus x squared over 1 minus x. Now the numerator is of the form a squared minus b squared. So you can factor it out as a minus b times a plus b. So it is 1 squared minus x squared, because 1 squared is 1. So this gives you 1 minus x times 1 plus x. This is how you factor it out. And denominator is 1 minus x, so this term cancels out, giving you 1 plus x only. And now when you just plug in x equals 1, you will get 1 plus 1, which is equal to 2. Okay, so are there any questions? Okay, so seems like there are no questions. If at any point you have any question, please feel free to put it up either in the chat box or simply unmute yourself and ask. So moving to the next question. Again, you have to find out the limit. This time the function is different. So consider the limit x tending to 0 of root x plus 1 minus 1 over x, where x tends to 0. And the options are: the limit does not exist, the limit exists and is equal to 0, the limit exists and is equal to 1, the limit exists and is equal to half. So again, I will restart the poll. Take a few minutes to answer. Okay, so let us now discuss the solution. Again, you will notice that if we put the value x equal to 0, then it will take the 0 by 0 form. So numerator will become 0, denominator also 0. So this is also again 0 by 0 form. So we will make use of L'Hopital's rule. And that means we will differentiate the numerator and the denominator with respect to x. Now plugging in x equals to 0, this gives us 1 by 2, option D. Again, another way to do this would be rationalization. So you have square root x plus 1 minus 1 over x. You can do rationalization, that is multiply and divide by the following. By this term. So a minus b, a plus b, that's a squared minus b squared. So a squared is x plus 1 and minus b squared, that's just 1. Now this 1 minus 1 cancels, giving us x over x. And again x in the numerator cancels with x in the denominator. So this is simply. Now you can plug in x equals to 0 over here and you would get 1 over 2 once again. So this is another way of solving the question. Okay, so next question now. So now we have a few true false type questions. State whether true or false. For a function f and c belonging to R is the set of real numbers. If the limit x tending to c f of x does not exist, then there exists a sequence Cn such that Cn tends to c but f of Cn is divergent. So this is true false type question. I will launch the true false poll for you. Okay, now we will discuss the answer. So the correct option is option true, and this comes from the definition for limit that we had. Remember, in the lecture we saw definition for limit in two forms. First one was in the form of sequences, and the second one was in terms of epsilon delta definition. So the sequence definition means that if you have a sequence Cn where n is greater than equal to 1, so if you have a sequence, and if this sequence converges or tends to a particular value c, and then if the function f of Cn also converges, if this converges, then the limit exists. So if the sequence Cn converges to C, and if the function of this particular sequence converges, then the limit exists, and the value of the limit will be the value to which this function converges. But here, if we have a sequence which converges to a particular value, but the function of that sequence is divergent, then the limit does not exist. And it is enough to show for one particular example, let's say one particular sequence for which the function is divergent, then that is enough to say that the limit does not exist. Okay, so next question. Question number 5, another true false type question. State whether true or false for two functions f and g and c belonging to R is again the set of real numbers. If the limit extending to c for fx gx product exists, then both the limits extending to c for fx and limit extending to c for gx exist. True or false? The poll has been restarted for all of you. Okay, let us now look at the solution. I see that some students have still not answered in the poll. All of you please answer the poll, and then I will proceed with the discussion of the solution. Okay, so the answer to this question is false, and let us see one particular example to prove it false. So let us take one example. Say let fx be equal to x and let gx be equal to 1 over x. Then let us consider the limit x tending to 0, where so c we are taking as 0. This is 0, but limit x tending to 0 for gx is not defined. However, if we take the product, this product fx gx, this is x times 1 over x, which is equal to 1, and clearly limit x tending to 0 for a constant function 1 will be 1, and it exists. So we have two functions, and the limit for one of these functions is not defined. However, the limit for the product of the two functions is defined. So this is one particular example which shows that this statement is false, that if the product limit exists, then both the individual limits for the each individual function should exist. Because you see here, the limit for the product, sorry, not this line here, the limit for the product exists, but the limit for one of the individual functions does not exist. And note that in order to disprove something, you need only one particular example to show that something is not true. However, in order to prove something, you have to be the most general case. You have to be like proving it for the most general case. and you have to prove it in a formal manner, and you cannot just show one particular example to prove something. You have to show it for infinite examples. That means you have to prove it in a mathematically formal way. But to disprove something, one particular example is fine, because that is just being used to show that something is not true. Okay, so that was question number 5, and we are now halfway through. There are 10 questions for today as well. So since we are halfway through, let us take a short break. Let us take a break for 5 minutes and then come back. Okay, so I hope everyone is back from the break now. Question number 6. State whether true or false. If f and g are functions such that the limit x tending to c fx exists and the limit x tending to c fx over gx exists and is non-zero, then the limit x tending to c gx exists and is non-zero. Okay, there's something wrong with the punctuation marks here. This should be a comma. Yeah. So state whether true or false. If f and g are functions such that limit x tending to c fx exists and the limit x tending to c fx over gx exists, then the limit gx exists and is non-zero. So we need to state whether this is true or false. The poll is up again for true false type questions. Take a few minutes to answer. Okay, so similar type of a question and we will answer it in a similar fashion. by using an example. So the correct option is false, and we will see how. Let us look at the following example. Fx equals x, and let gx also be equal to x. Now here we have limit x tending to 0, so c is 0 once again. Fx is 0, so limit x tending to c, fx is existing. And limit x tending to 0, fx over gx equals limit x tending to 0 of x over x, which is limit x tending to 0 of 1, and it's a constant function, so this limit is 1, and this is non-zero. However, if we look at limit x tending to 0 g of x, then this exists, but this is equal to 0. So this thing, this condition which says that limit x tending to c gx is non-zero, that condition is violated. The limit x tending to 0 of gx exists, but it is not non-zero, and hence this condition is violated. As a result, the correct option is false. So are there any more questions? So do you have any doubt? If so, please ask. Before we proceed to the next question. Also, if you face some network issues, then please head over to the YouTube channel to watch the live stream. The link to the YouTube channel has been put up in the Zoom chat box. Okay, moving to the next question. Let A, B, C, D belong to R such that A not equals C and B not equals D. Let f be a function defined by the following. It's a piecewise definition for the function. So fx equals ax squared plus b if x is less than 1, and it equals cx squared plus d when x is greater than equal to 1. State whether true or false. The limit x tending to 1 fx does not exist. So again, take a few minutes to answer the question. Okay, so let us discuss. Now here let us look, it's a piecewise function, so let us look that the limit extending to 1 fx for this particular segment. So putting an x equals to 1 here gives me a plus b, and x equal to 1 in this segment gives c plus d. Now a is not equal to c and b is not equal to c, hence these are not equal, and this upper one is the left limit because this is approaching 1 from the left side. It's approaching 1 from the left side, whereas this one is the right limit and it is not equal to it because it is approaching 1 from the right side. Left side meaning smaller than 1 and right side meaning greater than 1. So therefore the limit does not exist because the left limit is not equal to the right limit. The two limits from different ends are different. As a result, the limit does not exist, so this particular statement right here is true. The next question. For the function fx equals 1 over x minus 1, which of the following is true? Limit x tending to 0 fx exists, limit x tending to 0 fx does not exist, but limit x tending to 0 plus fx exists. Limit x tending to 0 fx does not exist, but limit x tending to 0 minus fx exists, or both limit x tending to 0 plus fx and limit x tending to 0 minus fx do not exist. This one is a multiple choice question, so I will launch the MCQ type poll. So the correct answer is option A, limit x tending to 0 fx exists, and this is actually a question similar to the first question for this week, where we actually found out the limit. And just for the sake of terminology, this x tending to 0 plus, this refers to the right-handed limit, and x tending to 0 minus, this refers to the left hand limit. And for this limit to exist, both the right limit and left limit should exist, and they should be equal. So so the limit exists, and limit is when right limit equals left limit, and in this case both those limits are -1. Now question number 9, the penultimate question. For the following function, show that the indicated limit does not exist. Limit x tending to 0 mod x over x. This is a subjective question, so there will be no poll for it. Instead, you have to try it on pen and paper yourself, and then we will discuss it over here. So let us now see the solution. Mod x is a piecewise function. It can be defined like so. It is plus x for x greater than equal to 0 and negative x for x less than 0. And if I were to plot this function, it would look something like this. Okay, this is not looking like straight axes. Let me try once again. Looks much more horizontal, I believe. Yeah, this looks much more vertical. Okay, so mod x is then a function as follows. So that's this red curve is mod x. So you can clearly see that this is plus x. So this is the x axis. This is y axis, which is mod x. And this side is negative x. So that's the graph for mod x. And that's why this piecewise definition. Now in this limit mod x over x as x tends to 0 plus from this end, so this is 0, so this is 0 plus, and from here left side is 0 minus. This will be limit x tending to 0 plus. So from the right side it is plus x, so x over x, which is limit x tending to 0 plus of 1, which is equal to 1. Now from the left side, x tending to 0 minus mod x over x. Now mod x as x tends to 0 minus is negative x. So this is limit x tending to 0 minus of negative 1, which is negative 1. Now clearly the left and the right limits are not equal, which implies that the limit does not exist. Finally, we move to the last question for today. This is a word problem, so you have to formulate the function yourself. Question number 10. A salesperson earns a basic monthly salary of rupees 800 and a commission at the rate of 15% of his monthly sales, and a bonus of rupees 1000 if his sales exceeds by rupees 10,000 in that month. He is also given a super bonus of rupees 2500 if his sales exceeds rupees 15,000 in that month. Write the income function of sales and find the points at which it is continuous or discontinuous. So again, it is a subjective question, so there is no poll for this. Try to formulate the function and solve this, and then we will discuss. Okay, let us now discuss the solution. So let X denote the sales and let Y denote the income. So we need to define this function. It will be a piecewise definition. So the first part is a basic salary of rupees 800 and a commission at 15%. So this is 800 plus 0.15x. This, and the next part is that if the sales exceeds 10,000, then he gets a bonus of rupees 1000. So that is 800 plus 0.15x plus 1000, and all of these are in rupees, that's the unit. And then if sales exceeds 15,000, then there's a super bonus of 2500. So and the regions are, this is for x less than equals 10,000. Here this is the first breaking point. Then for sales between then the next point is 15,000. So this is for x between 10,000 and 15,000, and this is for x greater than 15,000. So that's the function. Now let us look at these points 10,000 and 15,000. So limit x tending to 10,000 from minus, means left hand limit, of yx is clearly not equal to limit x tending to 10,000 plus from the right hand side of yx. So x equals 10,000 is a point of discontinuity. And why so? Because you see that at 10,000, at this x, from the left hand side you have this particular function, and from the right hand side you have this particular function, and there is this extra jump of sorry, I should not do it that way. There is this extra jump of 1000. So that is causing the discontinuity. Now the other point is 15,000. And so x equals 15,000 is another point of discontinuity. So let's look at 15,000. So again, for the left hand limit it is this function, and for the right hand it is this function, and this time the discontinuous jump is 2500. And because all of these functions are piecewise linear functions, that means they are continuous everywhere else except for these two particular points, 10,000 and 15,000. So this completes week 5 for us, where we discussed limits as well as continuity. So if you have any questions, you can stay back. Otherwise, the lecture is over from my end. Thank you very much, and we will meet next Saturday again at 3 p.m.